Hello everyone. So in this segment, we are going to learn about a new data structure, queue data structure. So let's start. So queue is a data structure that operates in the order of first in, first out. All right. So first in, first out, in short, we can say FIFO, FIFO means it's first in, first out. Just think about like a regular line. Okay, so here it's a line. We can think about like the line of person that may want to enter to a building or enter to a bus or train. All right, so here the first person in the line will be the first person to leave the line. Okay, so when this person will leave the line, so this person will be the first one. All right, then then this person, the person that is in the front of the line, will get the access first, means this person will be the first one to leave. All right, so queue is just a regular line, so which operates in the fashion first in, first out. All right, so insertion can be done at the end of the list. For example, like let's say the list looks like this. So this one is first, this one is the second, this one is the third, okay, in the line. So when there will be the new item, so what actually we are going to do, we are going to insert them at the end of the list. Okay, so this will be the last one. Now when we'll delete means which item will be the first one to leave the queue. Obviously that will be the first one. Okay, so that means when we are going to insert, we'll insert at the end of the list. When we'll delete, we are going to delete from the front of the list. All right, so now which one is the first item, I mean which one is the front item of this list? 2. So if we want to delete someone, if we want to pick someone, we're going to pick this one. Okay, let's say we want to insert another item, so that we are going to insert at the end of the list. And now we want to delete, we're going to delete this one. Okay, insert, delete, like this. So insertion will be like at the end of the list, and deletion can be performed from the front of the list. So the first added item has to be removed first. So what type of operation we are going to do in the queue? The each of the operation, like insertion, deletion, it has just a special name in the queue. So the insertion is known as the NQ operation. NQ means adding a item at the end of the queue. Okay, whenever we are going to add one item or insert an item in the queue, means we are going to add the item at the end of the queue. All right, so this operation is known as NQ. DQ means delete the item from the front of the queue. So whenever we want to delete something from the queue, we must delete whichever item is at the front of the queue. Okay, for example, in this queue we already deleted 1 2 3 4. So which one is at the front of the queue? 5. Okay, so if we want to delete something, we have to delete 5. All right, so no one can break the line. So we cannot actually delete, we cannot give access to any person before the person that is already in the front of the person. Okay, so we cannot pick anyone from the middle. So we have to pick the item which is at the front of the list, okay, or at the front of the queue. Peek means we can read the item for the front of the queue, means we can just look at the line. When we look at the line, we can only see the front person, okay, the first item in the list. So peek means we can just have a peek, or we can know which one is at the front of the queue. Is empty, we can check whether there is any item in the queue. All right, so preferably we want to implement all of the operation in order of one time. All right, so there are many applications of queue in the computer system. All right, so there are many applications that we can actually implement using queue data structure. So if there is an application where there are group of items and that are waiting to use some shared resource, Okay, so in that case we can actually implement a queue. So what does that mean is that, let's see, we have some server. Okay, so we have some resource, or we can say that we have some server. Okay, and that is going to be shared by a list of job. Okay, let's see, we have some list of application or list of job. So what we can do, like we can maintain a queue. All right, so we can maintain a queue, whichever the item is in the queue, in the front of the queue, that will be picked by the resource. That will be picked by the resource which is now ready to serve the job. Okay, for example, let's say there are three server, 1, 2, and 3. Okay, now these two servers are busy. Okay, now this one is now free to serve an application. All right, now which job it is going to pick? This is going to pick the job that is in the front of the queue. Let's say there are few application at the front of the queue. So let's say J1, J2, J3. All right, so this J1 is at the front of the queue. That means it's actually the first one that was entered in this CPU. All right, so this server is going to serve the application in first come first served basis. So J1 is the first one, it is at the front of the queue. That's how whenever a server will be free, okay, to serve an application, it is going to look at the queue and it will know that which job it is going to pick. All right, it is going to just look at the queue and it will see that this J1 actually it is the first one. Okay, so it is going to just pick the J1 and it is going to remove it from here. So then server, let's say the server 1 will be busy and it is serving application J1, job 1. At some point it will be free. Okay, so then now it's ready to serve an application, which job it is going to pick. So it will just look at this queue. All right, it doesn't have to need another program to see that which job actually came first. Okay, it is going to, if we maintain a queue data structure, it can just look at this list. All right, it is going to do a pick. That means like it is going to see which one is the first job. All right, so it will find that J1 here is at the front of the list, so it is going to pick J1. Okay, pick means DQ. All right, so here pick means we are saying that DQ. So when it will serve J2, we are going to DQ it from here and J2 will be served by server 2. All right, so let's see, now it will be busy with J2. All right, let's say there is another application coming in our system. So we are going to insert or enqueue at the end of the list. Okay, so when server 3 will be free, it is going to pick J3. All right, so if there is another application, we are going to add at the end of the list. So enqueue at the end of the list, dequeue from the front of the list. Okay, so that's how actually, I mean, you can see that if we implement enqueue dequeue in order of 1, all right, so the whole system will be much more efficient. So whenever a server is free and it is ready to pick a job, it doesn't need another program to know which job came first. Okay, which job came first? It can just look at the queue data structure, and by looking at the queue data structure, it is going to pick whichever is at the front of the queue. All right, it doesn't need any kind of traversal, or it kind of need to know which came first. Okay, it will just know that the first one in the front of the list, actually the first one that came in the application. Right, so that's how actually for this type of operation, if we maintain that as a key, if we maintain it as a queue data structure, the whole thing, I mean, is going to be very efficient, because here we are trying to implement, we are going to implement NQDQ operation in order of 1. Okay, so for example, like other application also, jobs in a single processing computer. So if you have only one CPU, all right, and you have multiple jobs for them also, You can just maintain a queue. Print spooling, same type of operation. So we are when we are going to print something, all right, so every print request actually maintains a queue. Okay, so everything like that we want to serve as like first come first serve basis, we're going to implement is like using a queue data structure. All right, same also information packets in computer networks, this kind of application, all right, can be implemented much more efficiently using queue data structure. So a queue looks like this. Okay, it's a list. All right, so when you insert in the queue, NQ means at the end of the list and DQ means at the from the front of the list. So for each queue we'll maintain two items, which is at the front, okay, and which is at the back or which is at the rear. All right, so from our implementation we'll know which one is our front and which is the rear item or which is the last item. But whenever we are going to dequeue the item, we are going to always speak from the front of the list. All right, so queue operation we are going to implement in our queue data structure. These are the operation we are going to implement: enqueue, dequeue, pick, and isEmpty. So enqueue, just we want to show you the example. Let's say we have an empty queue. So we want to enqueue 10. So 10 is our first item in the list. So this is our front. All right. Let's enqueue another item, 20. Now when we insert 20, all right. So what actually we are doing, we are maintaining this order. So this is our front. 20 will be inserted at the end of the list. Okay, so let's enqueue 30. 30 will be at the end of 20. Okay, so you can see that 10 is still front. Okay, 10 will be actually always front, not always front. When we are going to dequeue, okay, we'll see the example. So if we dequeue 10, 20 will be the front. Right now we're only doing the enqueue, so you can see that 10 is the front of the list. Then we're inserting 20. Then let's see enqueue 30. 30 will be inserted at the end of 20. Enqueue 40. 40 will be here. 50. 50 will be here. So this is the front of the queue. All right. So at this point, this will be our back of the queue, or we can also say that this is the rear. This is the last person, last item at the queue. Okay, at this position. So let's see, this is our queue right now. Let's see, we are going to dequeue. So which item we are going to pick? We are going to pick from the front of the queue. So we'll pick 10. Now 20 will be the front of the queue. Another dequeue, so we'll pick 20. Okay, now 30 is our front of the queue. Another dequeue, we picked 30. So 40 will be our front of the queue. Another dequeue. Okay, so let's see, we are going to enqueue something now. All right, so in that case we have 50 here, 60 will be inserted here. So 50 is front, 60 will be our back or rear. All right, now here doing another dequeue after 50, so we're going to pick 50. Now list will be, our queue will be empty. All right, so in the next video we'll see the implementation of queue using array and using linked list. Okay, and we are going to see the analysis of each of the operation.